Hello and welcome to Ambar Kelly's CPD on riser shafts and the importance of eliminating risk through design. We will begin this presentation by giving an overview of riser shafts and the challenges they pose. We will then look at the worst shaft fire in living memory to ask whether the construction industry is heeding the lessons learned from this disastrous event. We will explore the areas the industry must focus on to highlight the design considerations which must be adopted to ensure risk is eliminated at a project's earliest stages. We will then move on to give in-depth insight into current testing and regulations, and the materials used in riser construction and the misconceptions surrounding them. Our concluding thought will be one of simplicity, stressing the importance of eliminating risk through informed, efficient design undertaken from a building's very inception. Ambar Kelly started operating in 2009 as a specialist manufacturer and supplier of modular riser steel flooring. The product was invented and patented by Alex, the managing director. The invention arose from an experience Alex had when he was a project manager for a principal contractor. His boss at the time had taken him to task on the state of the risers. Alex asked what he should do, and the response he received was, "Invent something." He was aware that at the time, the current traditional protection was costly and caused delays on projects. So he then set to task with what he believed was required to protect riser openings. He knew the product needed to be cast in to eliminate the risk of falls from the offset. The material needed to be of a solid structure, durable and adaptable to allow for surfaces to pass through. Alex also wanted to invent something that met statutory regulations within risers. Ambar Kelly has a vast amount of knowledge throughout their team, gained from varying backgrounds within the construction industry. A key focus is on BIM, which ensures all disciplines come together early on, reducing on-site challenges where problems can be detailed out before they reach construction. Ambar Kelly work with principal contractors, frame contractors, architects, structural engineers, and MEP contractors. Our clients consist of the likes of Mace, Lend-Lease, Wilmot Dixon, BAM, Waits, McLaren, Multiplex, to name a few. Ambar Kelly are members of NBS. Our quality control manufacturing standards are CE marked and manufactured to execution class 2. All of our lorries are FORS Gold. What does the word shaft conjure up in your head? Think of 3 examples of building shafts. What was the worst shaft fire in living memory? It was the King's Cross London Underground Station fire on the 18th of November 1987. It took place at approximately 7:30 p.m. 31 people were killed and there were very many injured. But was it an accident waiting to happen? When the public inquiry carried out an investigation into the fire, the cause of the fire was a discarded lit match which fell on the timber escalator and rose up the escalator steps. When fire investigators started to examine the underside of the escalator, they discovered that there were 17 miniature fire marks from a similar activity. But the 18th one actually caught fire. What made the fire worse? Was it the shaft, complacency, or ignorance? During the public inquiry, computer modelling at the time identified the trough effect, where the flame laid down and superheated the first 20 meters above the fire of the wooden escalator stairs. This finding suggested that the fuel for the fire was the wooden escalator stairs, which were in use for 76 years. It was essentially a dormant fuel cell, an accident waiting to happen. For this reason, people that were investigating the cause of the fire questioned the results of the model. They carried out a practical test where they recreated the shaft to see if the exact same results would occur again in this real-life mock-up. And to their horror, they found it did, which validated the computer model. The King's Cross fire changed how shafts, tunnels of all types are designed, specified and built. With the last wooden escalator in the underground removed in 2013, what were the lessons learned from the investigation into the King's Cross underground fire? For the construction industry, the Grenfell tragedy has had many implications on building design and safety. Lessons learned from both the King's Cross and Grenfell fires include: to eliminate risk through design, to use the correct materials, take into account all the elements connected to the location, demand the appropriate testing for the intended use. Isn't it time the whole construction industry learnt from these lessons? In terms of riser shafts in tall buildings, the designers need to consider the risks that these riser shafts pose and document them in the principal designer's design risk schedule. These risks are well documented in HSG 168, Fire Prevention on Construction Sites, the Working at Height Regulations 2005, Building Regulations 2010, and Approved Document B 2019. The risks are fire and falls from height. Confusingly, the mitigation measures of the risk of fire is considered differently during construction and when the building is in use. For instance, if we consider a 42-story building with a basement and 2 plant rooms on levels 20 and 40, then fire compartmentation would be required as follows. For a building in use, as detailed in Approved Document B, 2-hour fire-resisting walls, as shown in Table B4 EI 120. 1-hour fire-resisting doors, as shown in Table C1 E60S. 2-hour horizontal fire stopping at compartment levels 0, 20, 21 and 40 provides 120 minutes integrity and insulation. For a building under construction, as detailed in HSG 168 and Fire Prevention on Construction Sites, design details that prevent the passage of smoke and flames up through a building during the construction phase. 30-minute horizontal fire stopping in shafts every 10 floors. In this case, levels 0, 10, 20, 30 and 40. 30-minute fire doors to all risers on all floors. Under CDM 2015 regulations, as detailed in Table 1 Designers, when preparing designs, need to eliminate, reduce or control the risks of fire and falls during both the construction phase and for the building's end use. So what are the options for the designers to eliminate, reduce or control these risks? Considerations could include: 1. Given that there is a need for a platform within the riser shaft on every floor when the building is in use, allowing for maintenance and servicing to be carried out on ducts, valves, electrical equipment and the like, could that floor be installed early or even cast in to prevent falls from traditional scaffold or platforms during construction? The answer is yes. Metal or GRP grating could be installed to the penetration shortly after casting the floor slab, or a modular steel riser flooring could be cast in. 2. Given the above, could the platform flooring be used to support the horizontal fire barriers for compartmentation required in both the construction phase and the building's end use? Approved Document B Volume 2, 10.25 states materials used for fire stopping should be reinforced with, or supported by, materials rated Class A2, S3, D2 or better. GRP grating is ENBS 13501 Class C-S3, D2 and so could not be used on fire compartment floors 0, 10, 20, 21, 30 and 40 in our example stated, so an alternative product would be required. 3. Given the answer to our first consideration, can the floorings identified eliminate, reduce or control the passage of smoke and flame through the building in its construction phase? Neither the metal grating or GRP grating can prevent the passage of smoke and flame. In fact, the latter will increase it, as you will discover later in the CPD, where we show evidence-based fire tests. 30-minute temporary fire doors will also be required for every riser opening. However, the cast-in modular riser steel flooring forms a horizontal barrier which effectively removes the riser opening for the purposes of the passage of smoke and flame. Thus, through design, the risk is eliminated, and the costly temporary fire doors can be omitted. When the M&E services are passed through the riser modular floor, it should be sealed with a soaker plate or incombustible material. The principal contractor has to avoid risk where possible. Advise the principal designer of risks. The client needs to understand the importance of the riser shaft and the risk posed to clients. Brand damage is greater than the cost of risers. Their responsibilities under the CDM 2015. One of the most forward-thinking developers in the UK is Land Securities, also known as Landsec. They have produced their own best practice guide called One Best Way Design Safety Instruction No. 4. Within this guide, the company has mandated riser protection within building design and has formulated a concise riser strategy which stipulates that health and safety are of paramount importance. In order to reduce risk through design, the CDM 2015 regulations, Construction Managing Health and Safety in Construction, should be consulted, as this document states to avoid risk where possible. Page 8, Section 5A. Digitization is going some way to reducing risk throughout a building's life cycle. It is crucial, therefore, to take advantage of the latest technological advancements into BIM. The BIM design builds everything in the virtual world, so when it comes to the real world, the risks have been reduced. All of the clashes have been removed, making for a far more efficient construction process. Regulations and testing. Have you identified the necessary interfaces for your strategy? Looking at riser risks and the regulations, there are 13 clauses which touch the riser zone from 4 different guidelines, regulations, and legislation. 12 of these clauses regard fire, and 1 is on falls from height. Are you designing to all the regulations? The following regulations include fire prevention on construction sites, Joint Codes of Practice, the HSE Fire Safety in Construction Approved Document B, and CDM 2015. When designing a building, have you reviewed the Joint Codes of Practice, as this will affect your insurance? Have you consulted the HSE regulations for health and safety? Does your design meet Approved Document B? And are you fulfilling your obligations outlined in CDM 2015? Approved Document B 2019 uses the European classification system for fire resistance set out in BS EN 13501-1. The standard classes are A1, A2, B, C, D, E, and F. Classifications for floor materials have slightly different tests, and the class above should be followed by the suffix FL, as in BFL. Rather unusually, the flooring within a riser is likely to be one product, and so the platform under your feet should be tested in accordance with the floor material test. However, the platform above you is a ceiling, so should be tested in accordance with the standard class tests. The designers need to take this into account when specifying riser flooring. Manufacturers and suppliers of GRP grating often state that they pass the superseded BS 476 Part 7 test as Class 1 or 2. Designers should review this data with caution, as the BS 476 Part 7 test cannot be carried out on a grating material, as grating does not meet the sample requirements, which is a flat sheet without holes. This would be classed as an opinion on an ad hoc test only. Approved Document B Table B1 transposes the national standard BS 476 Part 7 Class 1 as European classification C-S3 D2. The importance of material selection cannot be stressed enough. Therefore, it is essential you consider the combustibility and flammability of the products you specify. Materials burn differently in shafts. Scaffolding doesn't stop fire, and the wrong type of glass-reinforced plastic grating actually acts as a fuel source for fire. However, modular steel riser floors are an alternative which do not burn, nor do they add to the fuel loading of a building. Stopping the spread of smoke and flame is essential for the safety and well-being of everybody working on a construction site and through to building occupation and operation. Yet at present, falls from height and not fire is the focus purely because it is the visible risk. Without sufficient foresight, hidden issues go unnoticed. Currently, there is no relevant fire test within the British standards for riser shafts. But we have adopted a clever principle which has been informed by the public inquiry into the London Underground fire at King's Cross. An independent fire test was performed on a smaller scale to establish the burning characteristics of various products regularly employed in riser shafts. In this video, you'll see the real-time video, thermal video, and the temperatures. They are all synchronized to establish the visible burning characteristics of the most popular products used in the construction industry today. The 4 products in this video are ortho-resin GRP, iso-resin GRP, phenolic resin GRP grating, and modular riser steel flooring. From the videos you can see the ortho-resin GRP burns and can do so at temperatures above 670 degrees Celsius. The iso-resin GRP grating is said to meet BS 476 Part 7 standards, but also burns at temperatures above 670 degrees Celsius. The phenolic resin GRP is the only approved GRP product used in the London Underground. When we're thinking about the design of the riser shaft, we must be considering the regulations. We must be aware of the requirement to stop the spread of smoke and flame between floors to protect the construction workforce during the construction of a building. And when testing, we should be looking at the products employed in a riser shaft, as they have different burning characteristics. The last of these examples show the modular riser steel flooring. The temperature in the riser shaft never gets hotter than 54.2 degrees Celsius. The flames never reach above the first level on the diagrams. It lasts over 90 minutes with 1000 degrees Celsius underneath it, without any loss of integrity. This is the iso-resin GRP grating, which is said to meet BS 476 Part 7. In this video, it burns and reaches a temperature of 662 degrees Celsius. From this example, it is quite evident what happens when the iso-resin GRP, which is made from an oil derivative, burns at hot and dangerous temperatures. In fact, GRP grating cannot accurately be tested to BS 476 Part 7, as grating does not meet the test criteria. Testing of steel modular riser floors. The Fire Prevention on Construction Sites document summarizes that risers, shafts, ducts and similar openings between floors should be closed off with temporary fire doors on every level at every opening. However, if modular riser steel flooring is used on a project, temporary fire doors could be omitted, as this solution is a physical barrier to the spread of smoke and flame. Modular riser steel flooring also doesn't burn or contribute to the fire loading of a building. Caution needs to be exercised when gaps occur during installation tolerance for vertical MEP services and the floor plate. These must be closed off with a suitable temporary fire product to maintain the protection for 30 minutes. The regulations call for horizontal compartmentation within the riser shaft. It's very easy to create a horizontal fire barrier using pre-designed products, such as a modular riser steel flooring. If you take the examples in the two left pictures, the steel modular riser flooring would act as a barrier to the spread of smoke and flame for 1.5 hours up to a temperature of 1000 degrees Celsius and will not add to the load of a building. A fire compound can work in conjunction with the steel riser module to provide further protection. This meets regulations as it is non-combustible and non-flammable. When tested, it lasts for over 2 hours with 1000 degrees centigrade underneath it, proving integrity. GRB grating, however, after 7 minutes reaches a temperature of 214 degrees Celsius. At 12 minutes, it reaches 662 degrees Celsius. This diagram shows horizontal compartmentation in action. With a grating shown on the left-hand side of the diagram, it is necessary to employ, as the codes of practice dictate, 30-minute fire doors on every opening at every level. Yet in this diagram it is clear that a grating is not stopping the spread of smoke and flame. If the temporary fire doors are left open, fire will spread. However, if you use a modular steel riser flooring at every level, horizontal compartmentation is achieved. The spread of smoke and flame is wholly prevented, as the modular riser flooring is made of steel, which will act as a barrier to the spread of smoke and flame. These tests, which were carried out by an independent testing house known as the Building Research Establishment (BRE), showed no loss of integrity or insulation over 2 hours when combined with the fire compound and the modular steel riser flooring. This is a finished example from 52 Lime Street, London, of a horizontal fire protection barrier between a plant room and a shaft. These barriers are highly efficient if the right strategy is employed. In this example, you can see the modular riser floor plate has been recessed to act as formwork for a fire compound to be installed, offering in excess of 2-hour fire protection without loss of integrity or insulation. Let's look at the pros and cons. If we look at the pros and cons of scaffolding, the positives are: widely available, can be adapted as required, installed by trained contractors. The cons include constant adaptations due to design changes or delays in services being fitted. This has a heavy cost over the construction of a project for unplanned work. Time penalties for adaptations to be made. Scaffolding will not prevent falls from height and will not provide fire protection. GRP plastic rating. The pros include: it is easy to fit and adapt, cheap to buy, single function product. The cons: it burns fiercely, easy to affect its integrity, needs structural steel to support the grating when cut for services. There's working at height adaptations. It's flexible, but it needs strengthening. Flammable and combustible. Costs can escalate during building due to adaptations. Heavy captured carbon content, the highest in the industry. Modular steel riser floor. The pros: lowest outturn cost for the project. It's pre-designed. Has 11 functions across a project. It's a fixed price. There's no maintenance required. Does not burn. Built off-site. Prevents falls from height through the build process. No ongoing adaptations required. Last the lifetime of the building. Easy to recycle. The cons: higher entry price. Relies on early design. Needs buy-in from all parties. This is an illustration of a holistic riser strategy. At present, the M&D contractors sometimes look at installing riser modules in 3 floor lengths, which is about 12 meters. The illustration on the left-hand side shows a building which will be using 3-story riser modules. The diagram on the right shows single-story riser modules. We're encouraging the use of single-story riser modules, as they are quicker and easier to install, and allow other packages of work to be completed at the same time, so not to disrupt construction work. Single-story risers are inserted at every level with a hoist and are not crane-lifted into position 3 at a time, as would be the case with 3-story modules. On the left-hand side of this slide, the 3-story riser modules have not been installed, but on the right-hand side, single-story modules have been installed. In this example, the risers are being installed one at a time along with the other packages of work, such as M&D services and dry lining. It is a seamless process where everything is done in unison. Now the 3-story modules are only just being installed. Conversely, on the right-hand side, 5 floors have been finished completely. The single-story riser modules, the M&D services and the dry lining are all now in place. Adopting a single-story riser module strategy reduces total construction time by 7 to 8 weeks, making for an uninterrupted construction process without added costs and time delays. Furthermore, to meet the Codes of Practice and HSG 168, openings need to be closed off on every level. The riser shaft on the left has to be open all the way to the top for the 3-story modules to be installed, whereas on the right, the single-story modules seal every opening at every level, meaning fire cannot spread should it occur. Here are some examples of a single-floor height module. The electrical module is on its side and is lifted into a vertical position. The pallet truck wheels the unit over the top of the riser flooring and straight into position. It took less than 4 minutes to install this. There's no waiting around for the building to get to the right height before the modules can be lowered in. This is an example of an M&D modular installation system for 52 Lime Street. A mock-up scenario in which a single-story module was installed using a hoist and electric winches. This was installed quicker than a 3-story system that is crane-lifted into the shaft. In the video, the M&D single-height unit is being lifted into position in 2 minutes and 50 seconds. In this mock-up, it took less than 2 hours to install the system. This system was used on all 37 floors of 52 Lime Street. 3-story riser modules are considered a very efficient way to install mechanical, electrical and plumbing services. This graph, known as the line of balance, which is used by many manufacturers across the world, indicates that if you are completing a task on a weekly basis, you want all your materials and resources available at that time. But because of the nature of these huge 3-story prefabricated riser modules and the resources required to install them, the focus is on waiting until the building structure is at a height where they can get the most efficient method of installing these prefabricated riser modules. Whilst you're waiting for those to be installed and the building to reach a sufficient height for those to be installed, there is no other activity or follow-in trade which can carry on. You will note through these illustrations they are actually adding 7 to 8 weeks to the total construction program of a project. However, on this line of balance for the single-story solution, all packages of work are going in on schedule at a week at a time. Cost comparisons. What are the real benefits against cost? We have taken the standard 2.5 by 1.5 meter riser opening running up 11 floors and have modelled the costs of 3 more established riser zone protection products. You will see that we've split them into 3 separate and distinct methods. The modular riser flooring has been casted in. Traditional scaffolding, they're forming the house with the temporary shuttering and trims. The same with the GRP method. You will see that as they go through the construction cycle, that they're still constructing scaffolding GRP. The services are actually being fitted significantly earlier than the other 2 options. In the program, we established a 30% time saving in the construction of the completed riser shaft. Now within this video, we've identified the cost of the 3 established methods. You will note the cost for the modular riser steel flooring demonstrates the cost increases significantly at speed. But then a strange thing happens. The costs stop. When initially looking at the cost, most people only look at it from one perspective. When making a judgment based on price and not function, it will be obvious that people would select the cheaper product. But if you actually break down the costs over the life of the riser shaft on a project, you can see the cost of a modular riser flooring sits considerably higher. It is almost 50% higher than the GRP grating in the frame package. But we must understand that it's not just the frame package. It is the roofing, the dry lining, the general build, the builder's works, mechanical and electrical and the scaffolding costs over and above the costs of the full protection, which make costs grow. If you get it designed right first time, you have eliminated risks from falling from height, stopped the spread of smoke and flame, designed where the services will penetrate for fast, quick and easy installation in perfect safety, removed hidden costs or non-tangible costs which occur on every project that is unplanned. Here is a purchase perception graph. The horizontal blue line indicates the modular riser steel flooring cost, whereas the yellow line represents phenolic GRP grating, the only GRP grating permitted for use in the London Underground system. Commercial teams will analyse these comparisons and look to buy the solution in the phenolic GRP package, which they believe will save on cost and provide full protection. The initial cost of phenolic GRP compared to the modular riser steel flooring is lower. However, there are accumulative costs as the project progresses. Roofing, M&D, dry lining and scaffolding are costs which are not associated with the frame, but they do add up. It means the project arrives at an outturn cost far higher than expected. The cost of modular riser steel flooring, however, doesn't change, as it is a bespoke system which can incorporate all of these packages of work. To minimize project costs, it is crucial to start with the end in mind. Looking holistically at the riser shaft and considering its design from the outset will allow project teams to reap the cost savings. There are 11 functions of the modular riser floor. It saves money on shuttering and trims and removes the need for handrails, because if you haven't got a hole, you haven't got a risk. To put it simply, you don't need the handrails. It also stops the spread of smoke and flame between every floor, as it is a physical barrier to fire and smoke. This solution has a load-bearing capability of up to 2.5 kN per square meter. Depending on the design, the floor can provide a storage area for materials. It can be the formwork for horizontal fire protection and can be fixed points for separating walls and firewalls. It is part of the fixing points for mechanical and electrical services. It could be the casting of weathering properties for the top of service riser shafts, and it drives design to an early completion, regulation and testing. This video signifies that if a holistic riser strategy is adopted, the whole is formed and protected and lasts throughout a building's life cycle. It allows all the trades to work safely without risk and delays, making it completely safe for the construction teams and the building's occupants and users. Here are a few projects where modular riser steel flooring has been incorporated. One Crown Place is a mixed-use development in London. On this project, the principal team consisted of main contractor Mace and the concrete and steel frame contractor were Getjar and Severfield, Northern Ireland. Darmach Tower, another excellent example of modern architecture. This stands over 52 floors and utilised modular riser steel flooring on every opening on every level. It is one of the most technically challenging projects in London to date. For the One Triton Square project, additional floors were installed on the top of the original structure with a completely new design. Its new design connects the old and the new and was carried out to great success. As we end the CPD, the industry would do well to eliminate risk through design, change habits, understand the true cost, understand material selection, falls, fire, cost and time, eliminate risk through design. Remember to eliminate risk through design. Thank you for your participation.